Today we'll be going over learning target number 182. And learning target number 182 is about using the mirror equation. And with that, we are going to relate object distance, image distance, the focal length for the lens, and then we are going to use, we're going to determine image size in terms of object size. And the first and most important equation we will use is one over f is equal to 1 over di plus 1 over do. In this equation, our f is our focal length. Our do is our distance of the object from the mirror. And then our di is our image distance. The other equation that we need for this learning target is our magnification equation. So m is equal to hi over ho, which is also equal to negative di over do. In this equation, our m is our magnification. Our hi is our image height, and our ho is for our object's height. And we already know our di and our do. When we take hi and we set that equal to negative di over do times ho. Alright, so now we are going to do an example problem. In our example, we have a 4 centimeter tall object, and it is being reflected off of a concave mirror, and it is 45.7 centimeters away from the mirror, and our mirror has a focal length of 15.2 centimeters. And then we are going to determine the object's height and the object's distance. So to begin, we will use our equation 1 over f is equal to 1 over do plus 1 over di. It's pretty self-explanatory algebra now that we know the equation. So we will sub in our f. We will have 1 over 15.2 is equal to 1 over 45.7, I said? Yep, 7. Plus 1 over di. You can pull out your calculators or be super smart like Nathan DeGraff, and you will calculate that this is equal to 22.8 centimeters. We will calculate our image's height. To calculate our image's height, we will use our equation hi over ho is equal to negative di over do. We just solved for our di, so this should be very simple algebra as well. Hi over 4 centimeters is equal to negative, what was it, 22.8? Yep. Over 45.7. And do your math again. And then and we'll get our image's height to be negative 1.99 centimeters. And we know that it is negative because the image is going downwards. And since our image distance was positive, we know that it was reflected back into the mirror, and that makes it a positive number, which in turn leads our DI to remain negative in our equation, which is giving us a negative height, so it goes down. Yeah. Math.